SpaceX just revealed they've saved $1.8 billion by catching 6 million pieces of metal falling from space. NASA? They watch theirs sink to the ocean floor every single launch. How can SpaceX recover 99% of their fairings while NASA can't save one? Why does this mean NASA can't compete anymore? What's the secret behind this incredible achievement? Let's dive right in. Picture this. While NASA was burning $150 million worth of RS-25 engines into the ocean on every single SLS launch, SpaceX engineers were staring at a different problem. Two massive shell pieces worth $6 million each were falling from space at 300 miles per hour every single launch. Most rocket companies accepted this as the cost of doing business. But Elon Musk had a different reaction when he watched those fairings fall. It's like watching $6 million fall from the sky. And unlike everyone else, he decided to catch it. But here's what nobody talks about. This wasn't supposed to work. At all. Every aerospace expert said it was impossible. So why did SpaceX even try? Let's break down what SpaceX was actually attempting. Think about the difference between what they'd already accomplished and what they were trying to do. Rocket boosters? Those are engineering marvels. They have 9 Merlin engines, sophisticated guidance computers, grid fins for steering, and landing legs. When a Falcon 9 booster separates, it still has fuel reserves to perform a precise sequence of burns. It can literally fly itself back to a specific landing spot like a guided missile in reverse. But fairings? They're just expensive shells. When these nose cones separate at 60 miles altitude, they become giant gliders with zero control. No engines, no sophisticated guidance systems, no landing legs, just basic cold gas thrusters for orientation and a prayer that the parachutes deploy correctly. The physics working against them were staggering. Wind patterns at different altitudes would push them miles off their predicted course. Ocean currents made positioning recovery ships nearly impossible. Weather could turn a perfect recovery attempt into a $6 million loss in minutes. But SpaceX had a plan, and it sounded absolutely insane. SpaceX's first attempt was straight out of a Looney Tunes episode. They equipped 2 specialized ships with giant nets and tried to catch falling fairings midair. Seriously, giant nets. Imagine the complexity. You're trying to catch a refrigerator-sized object with parachutes attached, falling from 60 miles up while you're on a moving boat in choppy seas. The recovery ships had to predict where the fairings would land, position themselves perfectly, and then somehow snag these massive objects out of the air. It was like trying to catch a school bus dropped from an airplane while driving another school bus. The success rate? Under 2%. The ocean is massive. The ships were relatively small. Even a slight miscalculation could throw the fairings completely off target. SpaceX burned through millions trying to perfect this method. After countless failed attempts, most companies would have given up. But SpaceX made a decision that shocked everyone. They abandoned the nets completely, and then they did something even crazier. Instead of giving up on fairing recovery entirely, SpaceX decided to let them crash into the ocean on purpose. On purpose, every engineer said, "Are you insane? Salt water will destroy everything." But SpaceX had been thinking differently. What if they could design fairings that could survive an ocean landing? They completely redesigned the fairing's internal structure. All sensitive components were moved to the top section, away from where water would collect. They engineered the fairings to land upright like corks floating in water. This single design shift transformed a $6 million loss into a recoverable asset. But nobody believed it would actually work. The aerospace industry was convinced SpaceX was throwing good money after bad. They were about to be proven spectacularly wrong. Today, SpaceX recovers 99% of their fairings. Let me repeat that because it's so unbelievable. 99% success rate. That's not a typo. That's not marketing spin. That's actual operational performance. They've recovered fairings over 300 times, saving $1.8 billion in the process. But here's what's really insane. This recovery program has been so successful that it's now essentially funding SpaceX's next rocket development programs. Think about that for a moment. The money they're saving by not throwing away fairings is being reinvested into building even more advanced rockets. It's a virtuous cycle of innovation funded by recovered hardware. Meanwhile, let's look at NASA's approach. The Space Launch System burns through $2 billion per launch, throwing away components worth hundreds of millions of dollars. Those RS-25 engines alone cost $150 million each. There are 4 of them per launch. That's $600 million worth of engines dumped in the ocean every single time SLS flies. It's like buying 4 Lamborghinis, driving them around the block once, then pushing them off a cliff, and then doing it again and again. But the comparison gets even more stark when you realize what $1.8 billion actually represents in the space industry. Here's what most people don't realize. Fairing recovery was actually harder than landing rocket boosters. Way harder. Boosters have active control throughout their return journey. They can steer themselves and land precisely where they're supposed to. Fairings are passive objects that rely entirely on parachutes and basic thrusters. It's like the difference between piloting a helicopter and trying to land a paper airplane in a hurricane. Yet SpaceX cracked the code while every other aerospace company insisted it was impossible. But how? The answer lies in SpaceX's philosophy: question everything. While other companies accepted fairing loss as unchangeable fact, SpaceX asked, why does it have to be this way? That question led to revolutionary changes in fairing design, recovery procedures, and ultimately a complete redefinition of space economics. This is where the story gets uncomfortable for traditional aerospace. While SpaceX was revolutionizing recovery systems, NASA was still operating with a 1960s mindset. The SLS program represents everything wrong with old-school thinking. Every component is designed to be used once and thrown away. The core stage, boosters, fairings, engines, everything disposable. It's a philosophy that made sense in the Apollo era, when the goal was beating the Soviet Union to the moon at any cost. But using this throwaway mentality in 2025, it makes NASA look stuck 50 years in the past. The contrast is stark. For the cost of one SLS launch, SpaceX could launch Falcon 9 over 30 times, recovering most hardware in the process. That's not just a cost difference. That's a fundamental redefinition of space exploration. SpaceX's fairing success did something unexpected. It forced the entire launch industry to confront an uncomfortable truth. Reusability wasn't just theoretically possible, it was operationally profitable. Suddenly, companies that had spent decades insisting reusability was too expensive or too risky were scrambling to redesign their rockets. Rocket Lab's upcoming Neutron rocket, designed with reusability from day one. Blue Origin's New Glenn features a reusable first stage. Even ULA is exploring reusable engine recovery. These aren't coincidences. These are direct responses to SpaceX proving the economics of reusability work in the real world. Not just in PowerPoint presentations, but there's a deeper problem brewing for traditional aerospace companies, and it's getting worse every year. Here's the uncomfortable truth. SpaceX isn't just ahead of the competition, they're playing a completely different game. While traditional companies are still debating whether reusability is worth pursuing, SpaceX has already saved nearly $2 billion and is working on even more advanced recovery systems. The engineering mindset that made fairing recovery possible is now being applied to Starship. Super heavy boosters are designed to be caught by mechanical arms. The entire system is built around airline-like reusability. Think about the implications. While NASA spends 2 years and $2 billion preparing for each SLS launch, SpaceX is aiming to launch Starship multiple times per week. The economics aren't even comparable anymore. What makes SpaceX's fairing recovery even more remarkable is the context. This wasn't their only focus. They were simultaneously perfecting booster landings, developing Crew Dragon, building Starlink, and designing Starship. They weren't just solving one impossible problem. They were solving multiple impossible problems simultaneously. Each fairing they recover represents something deeper than saved money. It's proof that impossible is just another engineering challenge waiting to be solved. SpaceX's fairing recovery program forced them to develop new manufacturing techniques. When you're planning to reuse hardware multiple times, it has to be built differently from the start. Traditional aerospace manufacturing optimizes for single-use performance. Every component is designed to work perfectly once, then be discarded. But reusable hardware requires different materials, different assembly techniques, and different quality control standards. This manufacturing revolution has had spillover effects across SpaceX's entire operation. The same techniques developed for reusable fairings are now being applied to Starship development, engine manufacturing, and even Starlink satellite production. Meanwhile, traditional aerospace companies are still using manufacturing processes designed for throwaway hardware. They're not just behind in recovery technology, they're behind in the fundamental approach to building space hardware. When launch costs drop from billions to millions, entirely new possibilities emerge. Space manufacturing becomes economically viable. Commercial space stations become profitable ventures. Mars colonies shift from science fiction to engineering problems that can be solved with sufficient funding and determination. SpaceX's $1.8 billion in fairing savings represents more than just recovered hardware. It represents seed money for humanity's expansion into space. Every fairing they recover is funding research into closed-loop life support systems, in-space manufacturing, and interplanetary transportation. NASA's SLS program, by contrast, is consuming resources without generating the economic returns necessary for sustainable space exploration. Each $2 billion launch depletes the space budget without building the infrastructure for long-term space settlement. This raises the elephant in the room question that aerospace executives desperately don't want to answer. Can traditional companies adapt quickly enough to compete in this new economy? The answer is becoming increasingly clear, and it's not encouraging for the old guard. SpaceX didn't just develop fairing recovery in isolation, they developed it as part of a comprehensive approach to making space access affordable and routine. Every recovered fairing feeds into a larger vision of space industrialization. Traditional aerospace companies, meanwhile, are still optimizing for quarterly earnings reports and government contracts. They're playing for market share in an existing industry, while SpaceX is creating an entirely new industry. The most shocking part of this entire story? This revolution started with SpaceX questioning a single assumption that everyone else accepted as unchangeable fact, that fairings had to be thrown away. Every other company looked at fairing loss as an unavoidable cost of doing business. Industry reports, government studies, and academic papers all accepted this assumption without question. SpaceX asked one simple question: why? That question led to the development of recovery ships, redesigned fairing structures, new splashdown procedures, and ultimately a $1.8 billion savings program that's now funding their next generation of rockets. But the deeper lesson is about the power of questioning fundamental assumptions. While NASA and traditional aerospace companies were optimizing existing processes, SpaceX was reimagining what space exploration could look like if you started from first principles. Here's what makes this story even more compelling. SpaceX isn't slowing down. The same engineering teams that solve fairing recovery are now working on catching super heavy boosters with mechanical arms, developing point-to-point Earth transportation with Starship, and designing closed-loop life support systems for Mars missions. Each success builds momentum for the next challenge. Each recovered fairing provides funding for more ambitious projects. Each proven impossible technology makes the next impossible goal seem achievable. While NASA continues operating with throwaway rockets that cost more than many countries' entire space budgets, SpaceX has proven that the future belongs to those willing to challenge fundamental assumptions about how space exploration should work. The $1.8 billion they've saved on fairings alone could fund multiple Mars missions, build commercial space stations, or develop asteroid mining technology. Instead of watching that money disappear into the ocean, SpaceX is using it to build humanity's spacefaring future. And that's the real secret NASA can't compete with. Vision backed by execution, funded by innovation that everyone else said was impossible. So there you have it. SpaceX turned catching falling space junk into a $1.8 billion revolution, while NASA still burns money like it's going out of style. But here's the real question. What happens when SpaceX starts applying this same mindset to everything else? They're already catching rocket boosters with giant mechanical arms. They're planning to refuel rockets in orbit. They're designing closed-loop life support for Mars. If they can turn impossible fairing recovery into routine operations, What other impossible challenges are they about to crack? And here's what really keeps me up at night. While we're watching SpaceX rewrite the rules of space exploration, what breakthroughs are happening right now that we don't even know about yet? What's the next $1.8 billion secret they're working on in those Texas facilities? Drop your wildest predictions in the comments. What impossible space challenge do you think SpaceX will solve next? Because if there's one thing we've learned, betting against SpaceX being impossible hasn't worked out too well for anyone. Thanks for joining me on Space Core. Hit that subscribe button if you want to stay ahead of the space revolution, and I'll see you in the next one. SpaceX Flight 10 date just leaked through an official filing, and it's sooner than anyone expected. But that's not even the crazy part. They literally cut a hole into their launch tower and built a brand new connection system that's never been tested before. Will this revolutionary setup finally work, or are we about to witness another spectacular explosion? Let's dive right in. Here's what nobody expected. That Federal Communications Commission filing wasn't just announcing a launch date, it was revealing SpaceX's most desperate engineering gamble in company history. While everyone assumed August 4th was chosen because of Ship 36's explosion damage, the real story runs much deeper. Something happened after Ship 36's explosion that SpaceX hasn't told anyone, and now they're betting the entire program on a system that's never been tested. But why the rush? The answer will shock you. When Ship 36 exploded during its test flight, the damage wasn't just physical, it was psychological. SpaceX engineers discovered something terrifying in the wreckage, something that changed everything they thought they knew about Starship connections. Think about this. Every single Starship test before now might have been compromised by a flaw that nobody noticed. Every explosion, every failure, every setback, all potentially linked to a design problem that was